hopefully I understood. So I assume that means my turn. So good morning, everyone. I'm happy to see so many of you here. How many people do we actually have? Do we have a number-ish?
More than 200.
More than 200, wow. It's a lot of people. Well, I assume you got a short introduction. I heard my name and then he spoke some more and then I heard my name again. But so anyway, my name is Magnus Hagander. I'm a member of the Postgres core team. I'm one of the committers. I'm also on the board of Postgres Europe. So I'm sort of involved in all the sorts of different the open organizations. I've been working with Postgres for a long time. I think I had my first patch in Postgres back in, it was 95 or 96, which is, back when it wasn't really all that much fun to run into production. Up until today, when it's awesome to run into production. When I don't work on the pure open source project, I work for a company called Red Pill Info. It's an open source consulting and services company in the Scandinavian region. I'm out of Stockholm in Sweden myself. So, right next doors here, though it is my first time in St. Petersburg. So out of curiosity, for the people here in the room, how many of you have previously been to any sort of PG Day or Postgres conference or anything like that? Anyone? Yeah, that's not a lot of people. Well, I'm glad to see so many new people here, and big hand to these guys for actually pulling this together, and it seemed to be a very successful first attempt at a PG Day here in Russia with this many people on the first try. So I certainly hope you guys can keep that up, and we get more chances to show. So anyway, to some actual content, right? I'm here to talk about security. And let's start with the simple fact: security is hard, right? Does everyone think security is not hard? We have all sorts of awesome tools, but it's really hard. Even though we have all the tools, actually doing things right and using them the right way is really, really hard. We have so many examples of everyone knows, to get certification you need to use 128-bit encryption. So you invent your own encryption algorithm that's 128-bit, and then you store your keys on a post-it note on your front door and things like that. And the other important thing to know about security is there really is no one solution. So you're not going to end up here with, here's a nice recipe, here's how you make sure that your system is secure, because it's not that easy. In fact, there's never just one requirement. And that's the other bigger thing. All different systems have very different requirements. I see far too many, you can read a book that says, here's how you make your system secure. You can go to a training that says, here's how you build a secure web application or whatever. But it really isn't that simple, because what security means and what a secure deployment means is different for every single system. Yes, some systems are the kind that, the network should never pass outside the walls of the room that the server is in. Most people don't have that requirement. In fact, that would be a bad requirement for most of you, because you're probably serving up applications to customers, whether they're internal or external, and you don't want them all in one single room because it will be very crowded, at least if you're successful. If you have only one customer, then maybe it would work, but you probably don't aim for that. Whereas if you're in some areas of really high security corporations or high security government installations, it really is just that. Maybe not one room, but maybe one building. And that's a different kind of security requirement. And what Postgres does around this in general is it tries to provide you with a toolbox. And there's actually a lot of different security features in Postgres. You probably don't need all of it. In fact, some of you may not need that. Actually, you need some of it. Like everybody needs some of it. But most of you probably don't need the majority of what's actually in the toolbox. But it's there. And you can sort of pick and choose. And that's really what it's all about. It's about trying to figure out which parts of the toolbox should you be using at all, and how to use them. Because it's more important to pick a couple of good tools from the toolbox and use them right, than to just pick every single tool and just randomly throw it into the system and see what happens, basically. Which is unfortunately something I think we see a lot today in many applications, whether on Postgres or not, that people just sort of find every kind of security feature they possibly can and just enable it, without really thinking and without really planning. So this talk's supposed to be about secure Postgres deployment, and that's really the general idea, which means I'm going to talk a little bit about securing a Postgres environment, securing communications and authentication and user management in Postgres. What I'm explicitly not going to talk about is secure Postgres applications. Of course, if you actually want a secure system, you need both of them. Right? But things like authorizations and permissions and roles and security barrier stuff and row-level security and all that kind of thing, it's more of an application architecture thing. That's also important, but that's not what we're going to talk about today. This is more about the actual deployment of Postgres and sort of the system-level features that you really want to do. And the first thing you need to think about when you're trying to make a sort of secure Postgres deployment is really having a secure Postgres environment. Right? If you're deploying Postgres in an insecure environment, it will not be secure. Simple as that. You cannot get past that. Sort of the basic, if someone is root on your operating system, there's nothing you can do. They've already won. Likewise, if someone has physical access to your server, well then they can become root, and then they've already won. Or again, if someone actually has physical access to the data center that the server is in, then yeah, you may have it in a locked rack. But has anyone ever tried to pick the lock on one of these little door things on a rack? I've had to do that due to lost keys, and it's actually not that hard. If someone's in the data center, they know everything, they own everything. There's a matter of setting up sort of a layer of trust. Because you have to trust someone. You can't build everything and lock your building so that only you can get in, and design your own locks and all that kind of stuff. But you're not going to do that. You're going to get it at sort of a reasonable level. The other thing that I see a lot of people are missing in this whole sort of pure environment part is you need to really define your trust levels when you're working with something like outsourcing or just server hosting. You're placing your server in somebody else's data center. Do you know their security practices? Do you know who they're hiring? Do you know if they do security checks on their employees? Some data centers will actually publish exactly what kind of security checks they do on their employees, and some won't. If your system actually needs security, maybe you should be looking for that. If you're using a cloud vendor, do you know what their security practices are? Because that's just a sort of a massive size of outsourcing, which is, anyone who has root on an Amazon box, on the actual box, will implicitly have root on every single virtual machine running on Amazon. That's a lot of power. Now, Amazon actually has very good employee security standards, and it's not very easy to get root on an Amazon box. But it's a level of trust that between you and your provider that really needs to be part of when you're designing the environment. Because if you cannot trust that level, then there's really not much point in anything else you do. Because now you have a very weak spot where people can break into your system or do whichever they want. But sort of the next step down is choose the right operating system. Right? This is where people love to have one. Yeah, never choose this. Everybody should use OpenBSD or whatever. Use whichever one you prefer. Actually, use whichever one you know. Right? Somebody who knows how to securely deploy, say, a Red Hat system will deploy that more secure than that person will deploy OpenBSD. Someone who actually knows how to deploy OpenBSD really securely will probably make even a slightly better job. But you need something that matches up with your skill set. Same thing, if you're a 99% Windows organization, you hopefully have people who know how to secure Windows deployments, they're going to do a better job of that than they are going to do of securing a Red Hat installation. Because they don't know how to do it, they don't have the experience, they don't have the tools and things like that. So it's really well, make sure you use something you know. If you start with something that you don't know, then you're likely to make mistakes. And a single tiny mistake will just ruin sort of everything else that you were doing. And secure it at a reasonable level. Right? There are things you should do, but in general, most operating systems as we get there today are secure enough from an operating system perspective for running your database on. Right? If you're using something like Windows, well, they have templates that will set, yes, this is a server, and it's going to be secure, and those defaults are pretty good these days. If you're installing a Red Hat, or Debian, or FreeBSD, or whatever, the actual operating system level defaults are reasonably secure on pretty much everything. You're probably more likely to mess things up if you start changing them. However, that's sort of rule number one for any sort of secure deployment: no other local users on your database server. Right? Well, your DBA, actually maybe not even your DBAs, but sometimes your DBAs, but nobody else. Yes, there has to be a root account, but that's pretty much it. Don't let your users log into the server. Don't let just like random end users. Don't run your application whereby users SSH into the server and run something. Use the other sort of network layered securities between that instead. Because if you just get them right in there, there are many ways to get into the system. And now suddenly you have to spend a lot more effort on securing your operating system and securing your Postgres installation that you just don't have untrusted users on the system. It just opens up more attack vectors. When putting Postgres on top of your operating system, always use the standard installers if they are available, whichever platform you're on. Right? Don't go rack your own. Yes, Postgres is open source. You can build from source. You do it if you have to. But as a general rule, just don't go inventing your own things when they're there. If you're on Red Hat, use the RPMs, use YAML. If you're in Debian, use the Debian apt-get and things like that. If you're on Windows, use the package Windows installers. If you're on FreeBSD, use the ports installer. Because the guys who set those up actually know their operating systems very well. So they've set it up with good defaults. You're, again, much more likely to mess things up if you change it. It gives you also a sort of consistent security model across the operating system because they're integrated. Say you're using, again, on Red Hat, for example, all the Postgres packages will set the correct SC Linux context on files so that you don't end up with the classic Red Hat thing, which is, oh, things don't work, and you turn off SC Linux, oh, it works, okay, let's leave it off. But if you're actually installing, the approved RPM packages, they will set those things right, and you can keep running with SC Linux enabled, and it'll help protect the rest of your system. And that's sort of a general thing. The other thing that you get with those, and this is probably from all the things I meet out of my different customers, probably the biggest mistake that pretty much everybody makes, keep yourself updated. Right? Do not run on a 4-year-old Postgres minor release. Like 8.4, I ran into an 8.4.4 or 8.4.3 just a couple of weeks ago at customers. There's a multitude of security fixes. There's a bunch of other fixes as well, but from a security perspective, there's a bunch of fixes you just don't have. You're open to known attack vectors. Make sure that you keep yourself updated. And this obviously also includes the operating system. And in these 4 years, there have been quite a few security fixes to whether it's Red Hat or Debian or BSD. There's been a lot of them. If you don't apply them, you're open to known attack vectors. And that's just silly. If you're using something like Yammer apt, it just makes this easier because it's automatic. You can easily monitor it, plug it into your Nagios or whatever you're using, and it'll just alert saying, hey, the security fix is available. You should probably go install them. And as with all Nagios alerts, you all snap to attention and do it immediately, right? It's not how it works, but we can try. Trying to get sort of the next level under that, on the topic of encrypting the storage of Postgres, you can do it, right? Postgres stores all its files in a file system. So as long as you have an encrypting file system, you'll fix that, right? You will get performance implications, obviously. You may get reliability implications. You really need to look into your specific encrypted file system. There may be options that you have to set to make sure it works synchronously so that you can actually trust the data. But of course, the problem is even worse performance. But the thing to really think about is how do you deal with key management of an encrypted file system? What happens when you restart the server? If you're actually storing the key on the server, you might as well not bother encrypting it. Because the encrypted file system is there to protect you against someone physically stealing the server, right? Which is probably not that common. It's more common with an encrypted file system on a laptop, which gets stolen all the time. But if you actually have your key, even on a USB key that's stuck into the server, they're going to steal the server, they're going to steal the USB key. It's right there. You're not going to bother taking it out, and leaving it on your table. So key management is really the whole point. So what you need is offline. You might want to keep your key on a USB stick, but then every time you reboot the server, someone has to walk into the data center and plug it in. If that's the kind of security requirement you have, absolutely do it. But you probably don't have that. And again, just storing the keys on the server makes it completely pointless, and you're paying a fairly large overhead in just encrypting the disk. So you should probably not do that at the time. There's a slight diverging on this thing that might be worth thinking about is multiple instances. If you're running more than one Postgres instance on the same host, now in most cases you probably don't. If you have a single application on your server, it's a large-scale application, but if you have like multi-tenancy hosting or something like that, if you're running completely independent Postgres instances, you should probably have different operating system users for them. So normally you have an operating system user called Postgres that runs the server. If you install a second instance from a security perspective, you should now have a Postgres 2 or whatever you want to call it. Or let's call it Ingress just to confuse people, or Oracle or something like that. They'll try to hack something else. Now this is usually doesn't work too well with the package system because they're all hard-coded to whatever user they have. So you'll do things like edit the init script to make it work. But doing that will isolate them much more. Or in fact, other things that we have, you might want to consider like virtualization and containerization, just to keep these things even more apart, to separate them properly. Because if you have two servers running as the same user, you're actually the super user in one of the systems can easily hack the other system, because there's no operating system level security between them. And that's probably not a good idea. But actually getting the deployment, sort of the deployment on the server itself, Postgres, it's pretty simple. As long as you don't try to be cute and do something smart. Just do the defaults and you'll probably be just fine. Most people do not have requirements beyond the very defaults. Now something that tends to take a little bit more thinking is the actual communications between your application and Postgres. Because once you get in there, again, you need to make sure that you can just replay or you can read the data or copy the data or things like that. But really the first thing to think, again, here is choosing the right tools, right? Do you really need it? Like, what's the attack vector? Do you actually care about securing the communications? Well, if your application is running on the same server, probably not. Because again, if someone is root on your server, you've already lost. If it's in the same rack with a crossover cable, maybe that's acceptable as well. Because again, if someone wants to break into that, they're already standing next to your server. They might just take it and leave. If it's in your LAN within your organization, is it a problem or not? Depends on your organization. If it's a publicly internet-facing one, then yes. There's really no questioning. You really need to secure the communication in that case. Because there is an overhead, whichever method you choose, right? There will be an overhead of securing your communications. It's an overhead you should pay if you need it. But it's an overhead you should not pay if you don't actually need it. Which unfortunately a lot of people end up doing. There's a whole bunch of ways of doing this, right? Physical security is obviously the easiest. Just lock everything in one building and put an armed guard outside. And then we can just run clear text for everything. But obviously anything like VPN deployments or IPsec deployments, you may already have requirements elsewhere in the organization. This is an increasing number of organizations that just IPsec encrypt everything. Like all host-to-host communications are IPsec encrypted because you can, and then everything's secure and you have a single security boundary for your whole system. And if you have that, it makes perfect sense. And it's not that hard to deploy today. And once you've done it, you're in a good position because you don't need to tune the security of the individual products. And then, of course, we have the part that Postgres actually provides as a service for you, which is the ability to SSL encrypt the specific Postgres connections. Depending on what deployment is, it's easier or harder, but if what you're trying to serve is like road warriors with laptops connecting to the database, using a VPN might just be simpler, because they probably need a VPN anyway to access other things. For Postgres specific, the thing we do support and provide is SSL encryption of the connection. Now, Postgres SSL today is open SSL only. Sorry, that's what it is. We all love to hate open SSL right now. We're going to see so many more security vulnerabilities found in open SSL now that someone finally had the guts to look at it. But that's the way it looks. There are people working literally right now. I think Hickey, who will speak here later today, actually sent a patch in again. I think it's the 4th generation of someone sending in a patch to support multiple SSL libraries. We're not there yet, but we are going to get there. Obviously, like every other SSL service, you need a certificate and a key on the server, and that's actually pretty much all you need. Once you have that, you get SSL. Now, you don't necessarily get all you need, but you get SSL, and it's up and working. Now, Postgres has some interesting defaults, which is, by default, SSL is disabled on the server, even if you install the keys. Unless you run on Debian or Ubuntu, in which case they enable it for you, by default, every time, everywhere. But Postgres default is to have it off. However, on the client, it's enabled by default. So there's a mismatch in those two. Disabled on the server, it's enabled on the client. It's only partially enabled on the client. Now the certificates, when we're using SSL with Postgres, the server certificate is mandatory. You cannot run an SSL service without having a server certificate. You probably should not use like a public CA, go to VeriSign or Thought or one of those and buy a certificate for your database server. That's probably a bad idea. Because frankly, you should not have completely untrusted machines, unknown machines connecting to your database. For a web server, that's exactly what we have. We have random browsers around the world connecting, so we need a public certificate. For a database server, it will typically be our application servers. or maybe our own organizational laptops or something like that will be connecting. It's the devices that are known. So don't use a public CA. Create your own local. If you already have a CA in your organization, by all means use that, but don't use a public one. So-called snake-oil certificates or self-signed certificates will work just fine. Postgres has no reason not to work with that. You lose the manual and null protection. That's just a factor of how these certificates work in SSL. People will be able to hijack the connection, but you still get encryption. So it depends on sort of what you're really protecting against. But the general thing here is make sure you use a custom or dedicated CA to do it. There are trivial packages on Linux, there are trivial packages on BSD. I think it's even included in Windows if you're running Active Directory. You can get a CA, just use that. It's only a little bit of extra work and a lot of extra security because you get the ability to do a whole lot of things. Now to actually start running SSL on Postgres, it's very simple. You go into your postgres.conf, you say SSL equals on, unless, again, you're on Debian or Ubuntu, in which case they already did that for you, so it's already on. You put a file called server.key and a file called server.crt inside your data directory. Be very careful about the permissions of this. This is, again, not a Postgres-specific thing, but if someone gets to those files, they can hijack all your connections, they can access all your data. They're very secret files, they're very sensitive files. They should obviously, be in a mode that nobody else can read them. And this is the same, if you have the same kind of files for your Apache or Nginx or whatever you're running, and obviously it's the same level of security that's required, then you just restart Postgres and it works. Okay, now you have SSL. Now Postgres SSL negotiation works a bit different than you may be used to. If you look at, for example, Apache or any web, you have HTTP and you have HTTPS. They run on different ports, one is encrypted, one is unencrypted. Now Postgres, when it makes a connection, when the client makes a connection to the server, it will negotiate whether to use SSL. It's always on the same port. So you can't say firewall saying, hey, this port is encrypted Postgres, that's the only thing I'm going to allow. It's on the same port. What happens is basically the server provides SSL capabilities and the client decides whether it should use it. So the server starts by saying, hello, I'm a Postgres server and I can do SSL, and I can't do SSL. And then the client decides whether it's going to use that fact and actually use SSL or actually not use SSL. This is controlled by the SSL mode parameter, that's something you run into that's on the client side. And this SSL mode parameter is kind of silly. The default value is prefer. This is a really stupid default because it really doesn't make a lot of sense. What it says is, let's try to do SSL if it's possible, but if it's not possible, just keep sending things in clear text. Which means you get no guarantees whatsoever, right? I have this little table here of things that you can see. You've got, there are 6 different modes. You can say disable, allow, prefer, require, verify CA, and verify full. These are the different SSL modes that are supported. And as you can see, the first 2 columns here are what it protects against. What protects against eavesdropping and what protects against man in the middle. And as you can see, prefer doesn't actually protect against anything. Because if it were to use encryption, it would be protected, yes, but it doesn't guarantee that there will be encryption. So basically, it doesn't protect you against anything. The interesting thing over here is the performance overhead, right? If you turn SSL off, you don't get the overhead. If you say SSL allow, it means the client will do SSL if the server insists upon it. So we'll say we'll pay the overhead if necessary. Now prefer says we'll pay the overhead if possible, without getting any actual security benefits. That's kind of silly, and it's the default. Now if you actually want to get guarantees, you need to put at least require, or you need to put verify CA or verify full in it to get that. So the client may have SSL enabled by default, but it's not enabled in a fully secure way. If you actually need the encryption, you need to change this value on the client. Now the difference is require just says there needs to be encryption. Right? It does not care about the certificate at all. If you set it to verify CA, the client will verify that the server certificate is valid in the CA organization. Verify full will also match that the server's name matches the name of the certificate. Between those two, it does depend on exactly how you set up your CA and things like that, but you want to use one of those two to get the full security level on it. Now this is the other thing, right? The client decides really broken, doesn't it? And it kind of is. But the fact is, the client decides, but the server can reject. That's how it works. So the client can decide to say, I don't need encryption. And then the server can say, well, okay, then go away. You're not allowed to connect. For this, we use pghba.conf, that I'm sure you will run into. And we use the matching row type that's host SSL. So basically, your typical REST, we only do SSL over TCP, which kind of makes sense, right? Why would you do it locally? So you typically have a row out here that says host. You replace that with host SSL, and now this row will only match if the client's encrypted. So if you change all your host rows in your HBA file to say host SSL, if an unencrypted client connects, it won't be allowed to log in. You should always use host SSL if you're in an SSL deployment. Always. Should be not a single host line in your config file. Well, okay, maybe there should be one for localhost, but that's pretty much it. But when you're using SSL, you should be having host SSL here. That's the way that the server guarantees that it will only accept, secure clients. And you really need that guarantee to have a secure system because it's the server that houses your data. Client certificates are available if you need them. They're not required by default. So by default, Postgres will allow anybody to connect to the SSL, set up an SSL session, and then authenticate. If you require a client certificate, you just add the parameter client cert equals 1 to your, again, PGHBA line, so you can have different rules for different hosts. It will only require at this point that the client certificate exists and is trusted by the same CA. It doesn't actually verify the contents of the client certificate. But again, if you're running this in your organizational CA, you shouldn't be issuing certificates to people who shouldn't be allowed to log in, right? And if you're using a public CA, this is an excellent reason why you shouldn't be using the public CA. Because in this case, I could use my web server certificate to log into your database. You probably didn't intend that. If you actually do use client certificates all the way through, the default in Postgres is to accept a PEM format file for your certificates, just a file in your home directory by default in .postgres. But it also supports any OpenSSL compatible engine, as they call it. Which means basically if you have a smart card driver or a smart card reader with a driver that's compatible with OpenSSL, you can use that and just tell Postgres the certificate is on the smart card. And OpenSSL is going to read it from the smart card instead. So you can do very secure handling of your client certificates with it if you need. But again, by default, it only requires it to exist. And then it will perform a regular authentication once it's in there. Which brings me up to the next part, which is exactly that, authentication. There are a couple of simple rules. Like the first thing here is make sure, when we talk about authentication, this is the Postgres connection authentication, not the end user authentication. Right? And it's about making sure that it is the correct user that's on the other side that's trying to connect, and that they can prove that they are. So I'm going to take a step back and say one thing, which is step into the whole secure Postgres applications part, right? Because about the authorization and the roles you're in and all that kind of stuff, I said I was going to talk about that, but I'm just going to talk about one thing. Do not ever use the super user. Ever. Right? Nobody should ever log into your database using super user. Basically, allowing someone to do that disables all security in the system. The super user can do things like run arbitrary code. They can replace the security configuration in any way they want. Right? So basically, letting someone log in as super user disables all security in the system, both now and for the future, since they can change the configuration. Don't ever do that. Unfortunately, it's way too common that you see web apps just running as the super user because it's easiest. And yes, it is easiest, but it is also very, very stupid. So don't ever do that. So, going back to the authentication, how you prove that people are not supposed to be the super user. In Postgres, I'm sure you run into it, Postgres supports a lot of different methods using this technology that we call host-based authentication. In a lot of installations, you can combine multiple methods to make something that's really secure. And the sort of main rule around it is just, don't just dumb it down. Don't just go for the lowest common denominator. But actually look at what this system provides. Because with very little bit of extra effort, you can get a lot of extra security in your system. And basically, I'm sure, has anyone in here never seen a pghba.conf file? what I thought. The general idea here is we have a top-to-bottom file where we can filter on a combination of connection type user, database, and connection source. And both firewall the connections, having access to this extra information, and also decide how this user should be authenticated. So you can look at an example like this that says, if the user matches this, that's an unfortunate cutoff point. It's supposed to say peer. I promise you it says peer on my screen over here. It's just a little bit too wide. And then you see here is a classic one of those host SSL lines. It says only encrypted connections, etc. I'm actually not going to go through all of the rows here, mainly because I'm about to run out of time. And of course, update manager is not covering my song. And if nothing matches, so this is an important note, if nothing matches in this file, the user connection will be rejected. Use that. Like, what you can do is you can save this row and basically say that 0.0.0.0/0, which is the internet, can do an MD5 password-based login, and now you've done Postgres down to work the same as every other database. Don't do that. Use the fact that you can actually get extra features out of this. Again, there are a number of authentication methods in Postgres. It's actually quite a few of them. Some are internal, some of them are fully external, some of them are OS integrated, and some of them are really, really stupid. We provide those as well. It's to see, it's a test for you, right? If you use them, you are not worthy. Or something like that. For example, there is an authentication method that is called trust. What it means is trust everyone. There's nobody mean out there on the internet. Nobody's trying to hack you. Yeah, that's just a myth. What it basically says that whoever connects to the database can just say who they are and we will trust them. They say, hey, I am the super user, then we'll just trust them and give them super user privileges. This is not a good idea. In fact, this is a really, really bad idea. It turns off, again, all security is turned off. Don't do that. I sort of, in my days, I found a single use case where trust makes sense. Does anyone want to give a chance at guessing what the single use case I found where trust actually makes sense? Go stand in a corner and shame. You are correct here. Yes, resetting your password. Basically, if you lose your super user password, you have no choice. If you are on Windows. If you're on any platform other than Windows, you have a choice. But if you're on Windows and you lose your super user permissions, then this is your only way to recover it. So what you do is temporarily allow trust, log in, change it, and turn it off again. Don't forget this turning it off again. I've seen people do that too, but generally if you find trust, change it. Get rid of it. Consider it a security bug if you are using trust anywhere. That's really, really bad. Now what you'll probably, if you've installed Postgres on Linux, for example, you'll find your default being an authentication method called peer. This one is only available over Unix sockets. Yeah, sorry if you're on Windows. Sorry if you're a Java application, because the Java platform doesn't support it, even if it's on Unix. But peer will authenticate by basically, it only works with local connections, and it will ask your local operating system kernel who is on the other end of this connection. Now, if you don't trust your local operating system kernel, you have a bigger problem. Right? You have already lost. This is, by the way, how you recover your super user password if you're on Unix. Use peer. Now you can log in. But on the other hand, if you're on Unix, you should probably just use this and not even have a super user password. Because again, if you cannot trust your local kernel, you've lost anyway. So this is basically the highest security connection that you can make into Postgres. You should pretty much always have this on the line in PGHBA that says local users. The very basic one we have, and the simplest authentication method is called MD5. That's your typical username password. Right? It's called MD5 because it uses a double hashed MD5. It does one hash on the client, one hash on the server. The important thing to know here, there is another authentication method that is called password. If you use that, stop using it. It will send your password in clear text and it will store your password in clear text. You probably didn't want that. Don't use it. If you want passwords, use MD5. It's a little bit tricky that we're calling them differently. In fact, the only reason the password method exists is to make another deprecated feature work. So if you see password authentication, get rid of it. You don't want that. We have a couple of integrated options as well. You can do LDAP authentication with Postgres. To a Postgres client, it looks like a password. So you'll get a regular password prompt at the client, which has the advantage that you don't need any special client support. The client won't even know that you're using LDAP. It'll just get a password prompt. And Postgres will take that and just send the question off to an LDAP server, either using a prefix suffix, just constructing a URL, or connecting to the server, searching for the user, and then trying to authenticate with that user. Now, there are a few things to know about LDAP. One of them is that the password is in clear text. Okay, the password between the Postgres client and the Postgres server, if you're using LDAP, is clear text. Why is it clear text? Because Postgres server needs the password in order to send it to the LDAP server. Therefore, you should be using host SSL. Right? You should only be using this if you're on local connections or SSL. Never use it on a regular host connection. You should also set the flag LDAP TLS equals 1 on the HBA file. That will make Postgres encrypt the password when it's talking to the LDAP server. Otherwise, it will go in clear text between Postgres and the LDAP server. That may or may not be a problem. That depends on what the network looks like towards your LDAP server. But if you're on the network where you need the encryption, you need to set both of these. Again, it's something you need to look through. It will, in this case, apply things like password policies of the LDAP server, not of the Postgres server. It will only do authentication, so it's not going to copy over all your group memberships or something like that. If you need that, you need to write a little cron job that synchronizes things. A more advanced integrated authentication method is GSS or SSPI. This is Kerberos-based standardized protocol, particular GSS API. This includes full support for Active Directory if you're in an organization that has that. Probably the by far most widely deployed Kerberos server in the environment today. Now the difference here is this provides you with single sign-on, so there is no password prompt on the client. The idea is this: basically, once you've logged into the client, you're logged into the whole system, and you'll automatically be logged into the database, whether your client is a Windows laptop or your Unix machine or whatever. Basically, the idea behind Kerberos is when you log in, you get a ticket that the Kerberos system signs that says this person is trusted as being Magnus. And then whenever you connect somewhere, it'll just present that ticket saying, hey, here's the guy who's proven that I'm Magnus. It's actually a very, very secure protocol. It's designed to run secure authentication across the internet. So across completely insecure networks. Now, there is another authentication method that's called KRV5. If you're using that, it's time to start migrating away from it. That's the same sort of basic authentication in a non-standard protocol. Postgres 9.4 will remove this. It's been deprecated since 8.3, so it's been deprecated for a while. But it will actually be removed in 9.4. SSPI is a classic Microsoft embrace and extend version of GSS. If your environment is entirely Windows, you can use SSPI, and the advantage is it's already set up for you. You don't have to do anything to set it up, you just enable it and it works. No extra work. We have an authentication method called Radius. That's basically, again, it's just like LDAP, it looks like a password to the client, but it will send the password off the Radius server. Radius today is very typically used in one-time password solutions. If you have these little tokens that generate a one-time password, Radius is a protocol that they pretty much all support. Again, passwords in clear text, only use over SSL connections. Now the password to the Radius server is encrypted with a shared secret, but the password between the Postgres client and the Postgres server is not. We have an authentication method called cert as well, which is a certificate-based login, in which case we will now take this client certificate that you requested and we'll read the username out of it using the CN attribute. And again, any engine by OpenSSL. So this can give you a very secure. It can be pretty complex to set up and get running, but it will get you something that is very secure. I'm speeding up a little bit because I'm running out of time, sorry. I have a couple of minutes. Excellent. We also support something called username mapping. As you can see, some of these systems were external, right? We could use a certificate or Active Directory or something. Now, any external systems that provide you with the username. So the difference here is if Postgres goes to talk to GSS, for example, GSS will come back and say, this is Magnus. What if I want to be able to log in with a different username in Postgres? This is when we use username mapping. Same thing for peer. If I ask the local kernel, who's on the other side of this? I don't control the username. Whereas if I'm using LDAP, for example, actually the client provides the username that gets sent externally. So for peer, for GSS, and for cert, we allow either static or pattern mapping saying this user in the external authentication system is allowed to log in as a different user in Postgres. Actually, how you use it is fairly simple. You add in your PGHPA, you add something like map equals and the name of the map, which has again been cut off, but we'll live with that. And then you create a pgident.conf. It's one of those, it's named that because in the early days, only the ident authentication method supported this. More of them support it now, but the file is still named like that. And then you just create, so for each one, the first column here is the name of the map, local there, that's the thing that I have up here, that's been cut off. And then I just say the user root in the operating system is allowed to log in as the user Postgres. And then I can say, you know, the user Magnus in the operating system is also allowed to log in as the user Postgres. Maybe that's a bad idea. I'm not sure I'm to be trusted. And again, you can also do pattern matching. This is a very typical thing for certificates. So this is the cert that's up here with this certificate login. If the mapping here starts with a slash, it will do a regular expression match. And then you can use back references. Here you just say, well, if there's a CN equals in the CN name, that's a classic mistake, that the CN field contains the name CN equals something. You can just remove that and back reference into this. Another typical thing on certificates is you have maybe username @domain.com in the CN. You can just create a single line here that just removes the @domain.com and lets them log in. That tends to be a lot more efficient than listing every single one of your users in this pgident. But it is for mapping between these two systems. So again, using these authentication methods, use the right way, and you can lock things up a little bit more. So let's try to wrap this up a little bit. What about this secure Postgres deployment thing? The first thing you need to start with are these hard things, right? You need to determine what you actually need. Like, what are your requirements? What are your trust levels? Who do you actually trust? Server hosters, cloud providers, network providers, building maintenance. These are all actually there. What's your actual attack surface? Where can users or where can attackers get at you? Even potentially by breaking through another system, how can they get to you? What are the actual threat vectors? Where do you need to focus? Because you can probably spend months of securing a vector that nobody's ever going to hit. Put the efforts in the right place and deploy the correct countermeasures. Right? This whole idea of, I think it's a general sort of like the checkbox featuring, like, yes, we do encryption. And then you do it crappily. That's just useless. But you spend a lot of time implementing it. But you need to actually design these things. And again, you need to actually lock all the doors. It makes no sense to have excellent, perfect locks on the front door when you don't even have a back door. It's just open. Typical example is, why bother encrypting? Why bother encrypting your SSL connections if someone can just take your hard drive and walk away with it? If you have building security, they can do that. But if you just have a random server, they can do that. Right? Why require smart cards for login and then send all your data in clear text? It's just easier to intercept the data instead. So get it at the right level. And as always, and this is of course not a Postgres specific one, deploy layered security. Right? Don't fall for the good old, I have a firewall so I am secure. Right? A firewall does not protect you that well. On the other hand, that doesn't mean you shouldn't have a firewall. You should have a firewall as well. Because it's very easy to deploy and it takes away a lot of the simple attackers. But a firewall in general does not actually protect your system that well. And if you design your system based on, I have a firewall, then once that firewall breaks or someone gets through it, you have nothing. And you're completely screwed. There are a couple of those sort of Postgres specific ones that are just really too simple to mention, like don't use trust. Like really don't. Use PGHPA in a smart way. Don't set everything to 0000 MP5 and just say, because then I don't have to think about it. Do simple login saying, super user is only allowed to log in from the local machine. Only the web server user is allowed to actually log in from the web server. The DBAs are only allowed to log in from these specific IP addresses, which is where their office line is, something like that. And mix the authentication in the right way. Use SSL if you have to, right? It takes some work to set it up, but if you need it, it's worth it. Now, if you don't need it, don't pay the overhead. So basically, if you run a Debian or Ubuntu and you don't need it, go turn it off again. Because by default, they will encrypt your localhost connections, and that probably doesn't help you. But it costs a lot. It's actually, I like it like it's a consultant enabler. There's more than once I've come out to a customer who has a really bad performing system. I go in and turn off SSL and it's fine. It's like, easy money, but it's kind of boring to have to do that. If they were running like a Java application across the local host interface or something like that. It never makes sense to encrypt localhost. And remember that the security really is an iterative process. Okay? You are never done. It's not like, oh, I've set up my HBA file and enabled SSL, and now I'm secure. It's something that you have to go through all the time and reevaluate because your requirements change and the security landscape change all the time. Maybe someone deployed a new system on the server right next to it. Someone can now break in through that system if you didn't secure your network IP base, for example. So remember, you're never done. You just keep going over and over and over again. And that's it for now, I think. How are we doing? Do we still have time for a couple of questions? We have time for a couple of questions. So questions, if anyone.
Please tell us something if you know about the C-Linux support in PostgreSQL.
Sorry, what?
C-Linux support.
SC-Linux support? Okay, yeah.
PostgreSQL, not in Linux itself.
Yeah. So it's one of those interesting things. We have, since a couple of versions back, we have the support for something called SC-PGSQL, which is a module that lets you integrate Postgres with SC-Linux and basically give you labeled security inside of Postgres. It's one of those things. I'm sure there are a lot of excellent use cases. I know people who use it, who are not allowed to tell me what they're using it for. I've heard of organizations who basically were like, no, we can't use Postgres, we're not using Postgres, now we're moving everything to Postgres as soon as we got that support, but they also can't tell us exactly why. But the idea is really very high security installations can have use of this integration because it integrates all the way like from kernel security into labeled security in the database. Now there are issues with it along the fact that it sort of breaks the relational model in a bunch of places. Like you have a foreign key, and you're not allowed to see that something exists on the other end, but it still needs to lock your data and things like that. So there are some like philosophical controversies against the relational model. But obviously, if you actually need that level of security, you'll just have to deal with that and maybe not use foreign keys. Or, put that up in the application or something like that. So of course, I've never actually been able to. I've tested it myself, but I've never found an actual use case myself that I've been using it for.
Thanks. One more question, I guess. Please tell something about operating system level things like capabilities, groups, mouse spaces, and so on, if you know.
Well, Postgres doesn't do too much of integration with that because really it doesn't. I mean, it will respect whatever capabilities and things you have set in the system. So it makes sense to have capabilities like Postgres is not allowed to make network connections unless you're using like LDAP authentication or something, which case will only have to do that. Just like it will respect, SC-Linux restrictions and things like that. But I'm not aware of any efforts to sort of integrate that capability system into Postgres to be able to, set grant capabilities on tables or things like that. There have been some discussions about implementing a capability system inside of Postgres, but that would be a very separate thing. It's just something that would sort of work the same general way that you could assign capabilities to roles. But I don't think anyone's actually started working on it. Thank you. Did we have another question?
About role level security, how soon we will be to this feature in Postgres?
Role level security? I don't know. Nobody really knows. There's been a lot of progress now, and we have people who have had good funding to work on it. So at this point, I would say I hope we'll have some level of row level security in 9.05. It will not be 9.04, but hopefully in 9.05 we'll have something. Then it's a huge feature, so it's not going to be done there, but hopefully we'll have enough to make it useful in 9.05. So my current hope.
So soon, yes?
It's my hope, but again, it's not going to be done. But hopefully we'll have something.
Hello. Can you tell us about a situation when you need to give some access to single table to some user, and he ended up seeing all meta information of your database, including triggers, functions. Is this secure?
It's not great. I agree with that. The general thing is actually if you let users run arbitrary SQL in your system, they can do a lot of things. And yes, they can see the metadata. There would be good reasons to be able to restrict that. It's one of the things that I believe you can restrict using SC PGSQL, but that's a very heavy and complicated framework to restrict something as simple as that. Now, if your system security depends on users not being able to see what's there, you should fix your system security. But that doesn't mean that it would be good to be able to actually hide it. I assume you're referencing things like they can read PD class and the system tables, and yeah, it's not great, but I don't think it's a huge problem in general because it really only ruins it for you if you're deploying security by obscurity, which you should be doing in the first place. But yeah, it would be good to be able to restrict that, but it's not something we can do today. And the way the Postgres works, it's fundamentally very hard to do that.
Hello, two questions for me. Is it secure to use host names in HBA file instead of IP addresses?
That depends on your DNS, right? If your Postgres server is pointed at a DNS that you consider secure, preferably using DNSSEC, then yes, it is secure. If you're pointing it to your ISP's resolver machine, then no.
Okay, and second, if we use client certificates, does the Postgres check by default any location list?
It does not check the CRL by default, but you can make it check the CRL.
Okay, thanks.
That's all?
I think we left one all the way back there in the corner.
Я уже прошу с переводом. Для клиента какие методы, получается, возможны? То есть у нас идет идентификация радиус, LDAP, и все они выглядят как паспорт на клиенте.
Yeah, so from the client perspective, they're the same. There's really no difference between LDAP and radius from the client perspective. How you deal with it server side, well, it really depends on the server deployment. Typically, something like radius is simpler, and there's a lot to be said that simpler it's harder to make a mistake when you set it up, basically.
Сколько таких методов все-таки для клиента?
Well, there's the password one, there's the clear text password, there is the MD5 hash password, and then there are the integrated GSS, for example, which just has its own protocol. There is PAM has some exchanges that runs over its own. Certificate obviously uses the SSL channel. Off the back of my head, there might be some more, but those are the common ones.
Thank you.
Thank you.
Run.
No, it's okay.
Okay, we make some security system on the current iteration, and we want to know what in current time we don't have some intruders, how we can observe our systems on the security.
You mean like how to monitor the systems?
Yes.
Yeah. So Postgres has a fairly limited set of auditing, but a good start is to audit all connections and disconnections. Now the way the system auditing works in Postgres today, it just gets written to the log file. So it's probably a good idea to take that log file and load it into a system for actual analysis. That system may well be Postgres, but you'll then you get it to a file and then you load it into the file and you can do pattern detection, things like that. You will get, whenever someone tries to connect, for example, from an IP address that's not listed in your HBA file, you will get an error in the log file. Also, you can collect them, you can analyze them to detect patterns if you're getting, unusual amounts of authentication failures and things. Postgres itself doesn't contain the triggering or functionality itself, but it contains the ability to spit the data out in a format that you can analyze and then trigger on in one way or another in a monitoring system. And of course, monitor things like your host firewall and things like that as well, of course. Thanks. Thank you.
Okay, first of all, guys, I want to thank Magnus for giving his talk. It's really such a unique event, and we really hope that Magnus comes back to Russia for future events and continues to educate us on all the inner workings of PostgreSQL, and we share knowledge with us. So please, a round of applause for Magnus.
Thank you. Very happy to see so many of you actually show up here today, and hope you will learn something. Enjoy the rest of the day. Thank you.
Друзья, маленькое буквально организационное совершенно объявление.